All right. So in this lecture, guys, so the last two classes we did chapter 1 and chapter 2. This whole week it's gonna be chapter 3 notes, 4 sections, and it's gonna be the test 1 review. Now the test 1 review is not gonna be mandatory. If I have time to go over it in class, I will. But if not, guys, I'll probably just upload the review on Canvas and then I will upload the answer key like the next 24 hours or 48 hours. And they'll just be pictures, no videos of me working them out, just answers and work in the work. Um, I do recommend for you guys to work together if you can. Set up virtual sessions with each other or go on campus or meet at a Starbucks and just work on the review together. See if I can get the answers. If you can do the review comfortably and understand the steps to doing it, and the test is open review and open notes, you could use your stuff for the first test, guys. I I encourage you all to make sure you are doing any practice work outside of my class. Remember, the lecture isn't everything. You're not supposed to comprehend everything from the lecture. It's great if you do, but if not, you do need to push through the suffering that you're going through when you're working on these practice problems at home. I am seeing a lot of homework submissions, guys. There's some that I haven't been seeing, so keep in mind the due date is till the 31st. I'm gonna open up all of chapter 3 assignments probably either by today or by Wednesday for sure. Just depending how far we get along with the lecture. All right, guys. Without further ado, I'm gonna go ahead and begin the lecture. And then I'll probably take roll call towards the end of class. So if anyone needs to log off because of an appointment or because of something that happened, just write your name in the chat and say, hey, or send me a chat individually and just be like, hey, sir, I'm gonna be taking off because of a work or because of a work or whatever it is. So, because there's a lot of different reasons. So, all right, let's go. So the first thing we're gonna do is we're gonna do 3.1 simplifying algebraic expressions. All right, so I'm gonna go ahead and give you guys about 2 minutes to set this up into your notebook, about 2 minutes. All right, guys. So as I read the slide, so 3.1, simplifying algebraic expressions, which is things that we've kind of done already, but now we're going to go full into it in this lesson. So recall, an algebraic expression is pretty much a combination of numbers, variables, and operating symbols. Now, note, what are the terms of an expression, guys? The terms of an expression is, what is a term? A term of an expression is separated by a plus or minus sign. Now, before we go into an expression, let's break down the different terms you will see, like definition. So the first definition we have is a constant term. A constant term is a term that is a constant or number. So that's a pretty simple example to denote. So that's just like 7 or -4 or 2 or 2.5, just a number by itself. So i.e. A variable term is a term that contains a variable. So then we have x squared, we have 3y, we have 4z, anything with the variable, guys. And then the last component is the numerical coefficient. It's the number factor of a variable term. Like for example, 3y, the coefficient is the 3. The coefficient is the 3, and then the y is the variable. And notice how the definition says the number factor. The reason why it says the number factor is because we have to remember that 3y is the same thing as 3 times y. Every time we have a number and letter or variable next to each other, they're always secretly multiplying. It's not really much of a secret if I really want you to know that. All right.
Almost done copying.
Okay, cool. Let me know when you're ready.
Okay, I'm ready.
All right. Thank you for the heads up. Is there anyone else still trying to copy this before I move on, guys?
I am.
Can you let me know when you're good to go?
Yes, sir.
Thank you.
Okay, I'm done.
Excellent, guys. Anyone else? All right, let's move on. Next slide. So look at these examples of terms, guys. Let's write examples of terms. So look at look at this one here, x plus 3. How many terms do you think there are here, guys? How many terms? Do you think there's 1 term, 2 terms, 3 terms?
2.
2 terms. Now remember, what operation separates the terms? Either pluses or minuses. So you are correct, there are 2 terms. Now we have 1 term. What do we call the x? Is that a coefficient, a constant term, or a variable term?
Variable.
X is the variable term, and then 3 is the constant. Now look at the second example here. How many terms do you guys see here?
3.
That's correct. So I want you to understand this. The reason why I put this side in here, because I want you guys to be able to say, all right, there's this many terms here. This is what I see. There's 2, there's 3. This is the constants. These are variables, and so on. Go ahead and give you guys about 1 minute to copy this one down. All right. Does anyone need more time on this slide, guys? Anyone else?
No.
All right, guys, that was the 1 minute timer. So I'm gonna go ahead and move on to the next slide. Well, there will be expressions where terms have like terms, guys. Like terms are pretty much, they have the same variable factors with different coefficients, or sometimes the same. So look at the like terms box here. We have 3x, negative 4x. They're like terms because the variable coefficient, the variable term, the x is the same. Where 5x and x squared are unlike terms because the exponent's different. We can't combine 5x and x squared. They're 2 different things. Now look at the y. So that means like terms can be any variable, guys. Do not just be stuck to the notion of x only. There's going to be y, z's, a's, b, c, etc. Any variable may work. It is up to you to figure out which ones we can combine, which ones we can't. Like 7x and 7y, yes, they have the same constant, but they have the different variable term, guys. Would you guys like need 1 minute or 2 minutes to copy this slide down? I'm gonna give y'all 2 minutes.
So 7x and 7y, that doesn't mean the same thing?
No, it does not. Because like I remember variables is an unknown thing we don't know, right? We don't know what X could be or what Y can be. So I want you to take variables like different fruits at the grocery store. When you say, yeah, you don't say you have 7 apples and oranges, right? You would say you have 7 apples and 7 oranges. They're their own thing.
Oh yeah, but sometimes the problem will tell you what is x and what is y, right?
Yeah, exactly. Like those times where we plugged it in. You remember those problems?
Mm-hmm.
Excellent. And that's why you notice they're never the same thing because they're different variables. Good memory. Good one. I'll let you know when the timer runs out for me to move on if I needed more time. All right, guys, the 2 minutes just went up. Does anyone need additional time to finish copying this slide? Last call. Anyone need additional time before I move on? All right, let's go. And remember, guys, I am uploading every lecture on YouTube. I'm hoping you guys were able to access the last links easily. Let's keep going. So now we're going to learn our next property of this class is known as the distributive property. So I'm gonna go ahead and give you guys a moment to understand this. So while you write this, there's two components. It's this is equal to this, or you can also write, and I want you to write both. You could write C parentheses A plus B. These two mean the same thing, okay? The C doesn't have to be afterwards, okay? So I'm gonna go ahead and give you guys 2 minutes to write down this property. And then I'll go over what it means. All right, guys. Anyone still need any additional time to write this property down? All right, I'm going to write and talk about it. So the distributive property, if A, B, and C are numbers, then when we have AC plus BC, and you notice how they both have the C term, we can pretty much say that to get AC plus BC, we had two things in the parentheses, two numbers, A plus B times C. Notice how A plus B are both in parentheses. So what that means is this property, whenever we have a number or value outside of parentheses with multiple things inside, we can actually multiply and distribute that number to everything inside the parentheses. That's why we get A times C plus B times C, because we're multiplying the C to everything inside the parentheses. So notice how I'm drawing the arrows to kind of denote the distribution and where it's going to be distributed by. It kind of avoids those mistakes you make, like, hey, did I multiply this yet? Hey, have I done that step yet? The arrows will denote, oh yeah, this is this is that. So we're going to be using these arrows in the next couple of slides once we start doing examples off of distributive property. And you're gonna see how it's gonna come together. Make sure you ask questions if you're confused on how I do the multiplication, in case you're confused. But yeah, pretty much that's what distributive property means. Let's go ahead and keep going. So now before we get into distributive, let's go ahead and start combining like terms. So I'm gonna go ahead and give you guys about a minute to set up the example in your notebook. Now I'm gonna go ahead and go over A, B, and C. These are three different examples, okay? Example 1A, and B, and then C. So I'm gonna give you 1 minute to set this up, and then we'll get started. All right, guys, so let's look at example 1A. So we're gonna simplify by combining like terms. Now, the way you combine like terms, I always either underline or I use highlighters in the classroom. So look at 4x plus 6x. Notice how they both have the same variable term. They're both x terms. So remember I told you earlier in the last slide, I want you to think of different variables like different fruit. Well, 4x and 6x, would y'all clarify them as the same fruit?
Yes.
Yes, you can. So if you have 4 apples and you got another 6 apples added to your collection, in total, 4 plus 6 gives you a total how many apples? 10. But we don't write 10 apples, we write 10x, where we know x means apples. We just, and to get the 10, what did we just do, guys? I need you to understand what we just did. What did we do to the numbers?
Add.
We combine them.
We combined them, we added them. Everyone see that? All right, let's look at B. Now we have y minus 5y. Can I combine these, class? Can I combine y and negative 5y? Are they the same term, variable term?
Yes.
Yes, they are. Now, I don't know what kind of y this is, or what numbers in front of this y that I do not see.
Would it be 1?
Yeah, there's a 1 here. This is the same thing as 1y minus 5y. Well, guys, if you had one banana where y's are bananas, you have one banana, but I'm like, hey guys, I need you to give me 5. You give me the one that I had that you have. Well, now how many bananas do you have or own? What's 1 take away 5? How would you combine these? It's 1 minus 5. You have $1 in the bank and you spend 5. So what's going to be the combination of these two?
Is it negative 4?
-4 what?
Y.
That's correct. Do not forget the Y, ladies and gentlemen, okay? It's very crucial that you don't forget that step, all right? That we did 1 minus the 5y. Now look at C. Oh, let me question you on C. C, how many terms do y'all see in C?
3.
Excellent. There are 3 terms. Out of the 3, which ones can we combine, do you think?
3x squared and 5x squared.
That's correct. And now when we combine those, what operation are we going to do?
Addition.
So what's 3 plus 5? 3 plus 5.
7x. Oh, sorry,
So
7x
you're off,
squared.
you're off by 1. 3 plus 5 is you're off by 1.
I'm sorry, 8 squared.
There you go. Ax squared minus 2. Now, before I box, guys, can I combine the 8x squared and the minus 2?
Yes.
I hear a yes. Anyone disagreeing with the yes?
No,
Why not? Why do you say no?
because it doesn't have the same terms, I think it's called.
That's correct. Notice that, remember, because I remember every variable that's added to each letter or number, it's a different fruit. And the 2 doesn't have a fruit, I mean a letter, so it's not really a fruit. Does that make sense? Y'all see how we can't combine it because it doesn't have another x squared. That's the only thing that we can combine to this 8x squared is if it was another x squared term. Even if it had an x, let's say it was a 2x, we still couldn't combine them because the exponents are not the same. We have x squared and we have x, okay? Does everyone understand the difference on why we cannot combine this, guys? All right, I'm gonna go ahead and give you guys about 2 minutes to work on these practice problems. Good luck, everyone. All right, guys, that was a 2-minute timer. Does anyone have any questions about any of the practice problems you're working on? Does anyone want to share the answers or type them in the chat to see if other people got the same thing or different things? Anyone need me to work out any of them before we move on? Okay. Last call, guys. Everyone good?
Can I type them in the chat?
If you can, yeah, or you can say it aloud. Either one.
Okay. The first one I got negative 6m. And then the second one, 7a. And then third one, negative 4y squared plus 7.
All right. Does anyone disagree with any of these responses, guys? Or agree
I agree.
with all three?
Yes.
Okay. Anyone disagree with any of them?
I disagree with the last one.
So we disagree with the last one. What's your disagreement on which part?
With the negative 4y squared.
What did you get?
I got 2y squared.
Can you explain your reasoning on how you got the 2?
I subtract the negative y from the 3.
Okay, and what number is invisible in front of the negative y?
1.
So this is a -1, and then the 3 is you have 3, right? And you
Yeah.
subtracted because the one is what?
Negative.
Negative, right? And then 3 minus 1, what did that give you?
2.
There you go. Does everyone see that?
Yes.
Excellent. Thank you. Now, if you're ever trying to figure out how to add these values in your head and it's not clicking you, it's not you don't know what -1 plus 3y is. So another tip for you guys. So you know how we have -1y squared plus 3y squared plus 7. Well, we know the only thing that we can combine is the y squares, right? Those are the only terms that are the like terms. Now, if you ever want to use your calculator to combine these two, this is how you would do that. You would type in -1 plus 3. And whatever you get for those numbers, -1 plus 3, you type that into your calculator, your phone, or whatever, and you'll get 2. So that will be the combination of that operation. And all that you need to bring down after the 2, when you combine the -1 and the 3, you just bring down the y squared next to it. And that's one way to use your calculator to help you combine. Or you can use your fingers, be like -1, I owe $1, plus 3, I get 3. So the 1 cancels the 1 that I owe, I have 2 left. You see what I mean? There's a lot of ways to combine. You got to find what works for you guys. Thank you guys for the discussion. Let's move on. Now, these are important properties in mathematics, and I'm really wanting to show you guys these properties so you can see them in action, because these properties are what makes mathematics works. These properties have been proven that they exist, which allows us to create the way we understand math in the classroom. So I'm gonna go ahead and give you guys about I will give you 4 minutes to copy this slide down, because there's examples underneath this, the properties, there's helpful hint on real examples of these properties, and then I'll go over them quickly. So I'll give you 4 minutes starting now. So in this slide, it talks about the properties of addition and multiplication. So let's look at the property, how it starts. It says if A, B, and C are numbers, then A plus B is equal to B plus A. And that is called the commutative property of addition. So that's saying that the order, and now let's look at the next commutative property of multiplication, saying that A times B is equal to the same thing as B times A. So that's pretty much emphasizing that the order of adding or multiplying two numbers can be changed without changing their sum or product, where sum is the answer, pretty much the answer of addition problem, product is the answer of multiplication. So that's why we have this example here. 2 plus 3 is 5, which is the same thing as 3 plus 2, which is kind of, and this only works for these two operations of addition and multiplication. Notice how it doesn't bring up division nor subtraction, okay? Now, the bottom half, which is A plus B plus C, and AB has parentheses. Remember, we will have to follow PEMDAS, right? So what this property, what the associative property of addition is saying is that you can actually move the grouping. You can add B and C first, because remember, we add from left to right, right, using PEMDAS. That's why we have A plus B here in parentheses. We would add these two up, and then, so let's pretend A, B, C is 1, 2, and 3. Well, 1 plus 2 is 3, plus 3 is 6, right? But now here, they want us to add the 2 and the 3. And we know B plus C, 2 plus 3 is 5, plus the 1 here, it's still 6. So what this property, what the associative property is saying, and it works out with multiplication too. When you have three numbers multiplying, you can multiply the first two to the left first, or you can do the last two and still get the third one, and it's still not change the sum or the product. So pretty much saying that the way you group the adding or multiplying would not make a difference either. That's what these properties are telling us. Like 7 times 9 is the same thing as 9 times 7, which is 63. The associative property is impressive because 1 plus 8 is 9 at the 10, 19. Over here, we change the order up. We add the 8 and 10 first, which is 18, at the 1, and it's still a 19. Notice, so it's pretty much how these examples here down here are really showing you how these properties actually work with numbers. They're not true for subtraction or division, okay? I don't want you to get those confused. Now, before I move on to the next slide, guys, is there any student that is still taking their time to write this so I can add an extra minute or two before moving on?
I
Hurry up.
am.
Would you would 2 minutes be good enough or more than 2?
Like 2 or 3, yeah.
I'll start with 2. We'll see how it goes. All right. Was that 2 minutes enough, everyone, or should anyone need more time?
I'm almost done.
Let me know when you're good, okay?
Okay, I'm done.
All right, thank you for the heads up. All right, guys, we just finished these properties and this helpful hint. I now, if math and science, if you're not gonna study STEM like computers and stuff, I don't or STEM like science, technology, engineering, or math. You don't have to remember these properties by memory, guys. You don't, especially this is like the only math class you need, or you need this one and one more, and that's all you're ever gonna take. Then don't stress heavy on these properties. But if you are going to study science or technology, engineering, or math, I highly recommend you remember these properties because you are going to see them in the other classes, and it's going to be expected of you to know what they are and what they do. So let's look at example 2, guys. I'm gonna give you about 1 minute to set it up, and then we'll get started. All right, class. Let's go ahead and look. All right, example 2. I want you to simplify things. It has 2y minus 6 plus 4y plus 8. Now, class, are there any like terms right away when you look at this? Do you see, okay, I could probably combine this, that with that, because what do you
There's
think?
2y and 4y.
Okay, good. And what's your justification for that? Why can we combine those two? Because they both have a what?
A y.
Excellent. Now, are there any other like terms we can group together, guys, that you think?
The 6 and 8.
The 6 and the 8. Now let's go ahead and combine. Notice how I'm color coordinate. Now, if you don't want to do color coordination, guys, you can do shapes. Like, for example, you could put a square around 2y and a square around 4y. And then we could put a circle around the 8 and a circle around the 6. I included the minus with the 6 because I want everyone to remember that it's a negative number we're subtracting from. So let's combine the two squares. When we combine 4y and 2y, what's 4y plus 2y, y'all? What do we get? Remember, we're gonna add them because they're both positive. So what's a 2 plus 4?
6y.
That's correct, 6y, because we have 2 plus 4, which is 6. Now let's combine the circles, negative 6 plus 8. So look at the way money, negative 6. You owe the bank 6, right? But guess what? You found $8 on the floor. So when you put the 8 into your account, what's your balance? Are you still gonna owe money, or are you gonna have money to spend now?
Have to.
You're gonna have to. Now, can I combine these two guys, 6y plus 2, and get 8y? Can I combine them?
No.
No.
Excellent. That's the biggest part about this example is, can we combine and do more? No. If you're able to tell me no or no in your heart, okay, yeah, I can't do anymore. I can box. That's excellent. That's what I need you to get to. So I'm gonna go ahead and give you guys about 1 minute to do practice 2. Good luck.
Hmm.
So we are combining, and if you want to put your simplified expression on the chat to see if other students got the same thing. That was a 1 minute timer. Anyone need more time on the practice problem? Anyone want to share with the class what they got? Whether it be the chat or unmuting themselves. 6z plus 5 plus z minus 4.
I got 7z plus 1.
7z plus 1. Anyone disagree or agree with 7z plus 1? All I need to hear is at least one student to agree or disagree. Oh,
I
I see.
agree.
Agree. Okay.
Agree.
Excellent. Excellent. Everyone with me so far with the lesson? Any questions before we keep moving on? Because it's gonna get a little more complex as we keep going, guys. More and more is gonna be added to the processes we're doing right now. So just make sure you're all staying with me, all right? All right. Let's move on. Examples, we have three more examples here, 3, 4, and 5. We're gonna combine like terms. I'm gonna go ahead and give you guys about 2 minutes to set it up in your notebook, and then we're gonna go ahead and I'll solve these with you. Now, if you want to try to solve these on your own, you can and see what you can do. I encourage it. Now, if you're writing I recommend it to be pencil though, because in case you made a mistake, you can erase it. Now, if it's pen, you live your life. I'll see you in a minute and 30 seconds. All right, let's take a look at the first example 3. 6y plus 12y minus 6. You got to be able to look at that expression and be like, all right, what am I going to combine here? Now, since this is an example, I'm just going to work it out. We have 6y and 12y that we can combine. And we're combining them by adding them. So we have 6 y's, we find 12 more y's. In total, we get 18y. Bring down the minus 6. And we're done. Now, I always want you to start off with the letter first, and then the constant term is always last. Always end on the constant term. Now, if you have multiple letters, like in example 5 right here, down here, you can go alphabetical order. Do your X's first, your Y, and then your Y's, and then your constant term. Let's look at 4. We have 4x plus 2 minus 5x plus 3. So that's going to tell us we're going to combine a couple of things actually in example 4. It tells us that we can combine 4x with minus 5x. I'm going to include the sign now from now on. So we know it's as a negative. And then we're going to go ahead and combine the plus 2 and the plus 3 because they're both constant terms. Well, let's go ahead and combine them. Well, let's combine the x's. 4x minus 5x. Well, I have 4. I spent 5. Well, I'm gonna owe 1 to whoever I went to the store with. Plus 2 plus 3, that's just a total of 5. And we're done. Now we're on the last example here. And I'm gonna go ahead and you see what and now I'm gonna use shapes for this one. I'm gonna circle all my x terms that I can combine 2x with, which is this 4x over here. Then I'm gonna go ahead and put a square around my constant. And so I'm doing these shapes in case you don't have multiple highlighters in your disposal and you want to use a technique. This is the shape technique for combining like terms. So I'm gonna put a square around every constant term, which is just the 11. And I'm gonna go ahead and put a heart over the y's. And now we combine. Now remember, we want to go alphabetical order first. So we're going to combine the 2x and the 4x first. 2x plus 4x is a total of 6x's. 6x. Let's combine the y's. We have 3y minus 10y. Well, luckily I have 3, but I'm spending 10 at the store. So I'm not going to have enough to cover the 10 because I only have 3. So I'm going to owe them 7y. So since I owe them, it's going to be minus. And then for the squares, we have -5. I owe the bank 5, but luckily I made $11 from Lyft driving. So I put the 11 in my account. The bank takes the 5 and I'm only left with 6. I have 6, so it's gonna be a +6. And we're done. What questions does anyone have on any of these examples that we did, guys? For those of you that did it by yourselves, were you able to get what I got? Did you make a mistake somewhere that you want to talk about so other students can see if they make the same mistake? Anyone want to discuss what the reason, anything about what they got? Any questions? It's pretty straightforward. I might add. All right, because you guys are gonna have some practice problems right now in the next slide. So any questions before you work on these practice problems by yourself? All right, ready? Here are your next practice problems. I'm gonna go ahead and give you guys about 5 minutes on these set, okay? Now, before I start this timer, was anyone still copying these examples before I move on to the practice problem? Anyone still copying this? Last call. All right, 5 minutes for these 3 examples starting now. Good luck. 18y minus 6. Does anyone agree or disagree with number 3?
Agree.
Excellent. If anyone agrees, feel free to type in the chat or unmute yourself. Anyone want to share what they got with for number 4?
I got AY plus 3.
8y plus 3. Does anyone want to agree or disagree with the solution for number 4?
Agree.
Excellent, guys. Excellent. And what'd y'all get for number 5, guys? The last example. Anyone want to share with that?
Oh, I got negative 10x minus 9y plus 40.
Does anyone agree or disagree with this solution?
The only thing I probably did wrong was, did you say we have to do like alphabetical order, like X and then Y? Because I did Y first.
Ah, um, in this lesson, no, since you're barely learning about that order, but moving forward, I would recommend you to start this notation alphabetical order,
Okay.
just so you can get ready for that college level. Are there any questions on these examples or these practice problems before we move on, guys? Any questions, comments, or concerns? Okay, you guys are doing excellent, by the way. I'm loving y'all's discussion. I'm loving that you're getting the right answers. You're on the right track, ladies and gentlemen. All right, we have some examples, 6 and 7. I'm going to give you guys about 1 minute to set these up before I work them out. So the examples, this is example 6, and then this is example 7. All right, so this is what we're gonna multiply. So I'm gonna give you a minute to set it up, and then we'll All right, let's begin. So in example 6, we have 5 times 3y, guys. So 5 times 3y, since we're in parentheses, denotes multiplication when they're next to each other. So what we're doing is we're just going to multiply the 5 times the 3y. Whenever you're multiplying a number with a variable term, you're only going to multiply the numbers. We're going to apply the associative property and just do 5 times 3 first, and then just attach the y to it afterward. So 5 times 3, we all know it's 15, and just bring the y next to it, which we know is 15 times y, but I want you to just write 15y, and we're done. Multiplying is not too complicated. And over here, example 7, we have -2 times 4x, which we can go ahead and do -2 times 4 instead, and then bring the x next to it. And we know a negative times a positive is a negative, and 2 times 4 is 8, and don't forget the x. So -2 times 4x is -8x. Now, since we're going to be multiplying things in the future from now moving forward, remember this: positive times a positive is positive, a negative times a negative is a positive, positive times a negative is a negative, and a negative times a positive is a negative. So remember this, because we're going to be utilizing it as we start multiplying things out. You need to remember the correct sign that you get, and because if you get the wrong sign, if you put up a positive 8x here, that's wrong, because we have a negative and a positive, which is a negative here. So you need to understand the properties of multiplying integers, like whether it be positive numbers, negatives, or one and the other. Any questions, or what questions do we have so far on these examples? We're just multiplying across. Anyone still need a minute or two to copy this down before I move on? All right, let's keep going. So example 8, use the distributive property to multiply. So go ahead and I'm gonna give you about 2 minutes to set up example 8. And if you want to skip like 4 lines or 3 lines to go to 9, you can, or just, I'm gonna give you 2 minutes to set this up. Or a minute, actually, I'm gonna give you a minute to set up example 8. All right, guys. So I finally just got the response about the census date. So today's the last day you guys can drop any class without going on your transcript, guys. So keep that in mind. Today's the last day you can drop before. If you drop after today, it's going to show on your transcript. Just keep that in mind, not just for my class, but for any other classes you're taking right now that may not be so positive for you. But talk to your advisor, reach out to them today if you need to do something like that. All right, let's do example 8, using the distributive property 5 parentheses x plus 4. Now I'm going to rewrite that in the next line here, 5 parentheses x plus 4. Now remember, when we distribute when we use the distributive property, I want you to use arrows from the 5 to put it everywhere inside, to every term inside the parentheses. And there's only 2 terms in here, the x and the 4. So what the distributive property means is we're gonna multiply the 5 to the x. So we're gonna have 5 times x here. So 5 times the x plus the 5 times the 4. Notice how the 5 is being multiplied to everything inside the parentheses. And now we just simplify. 5 times x, y'all, is just 5x. 5 times 4 is a positive 20. We ask ourselves, can we combine these? No, we cannot. So we are done. And that is the application of the distributive property. That is how we do it. I want you to go from the arrows to writing this step out where you're multiplying the term to each term inside and then simplifying it. I want that to be your process in these examples and your practice problems on the next slide. So that way you can build that confidence. And as soon as you're like, I know what I'm doing with those arrows, you can omit the middle step. I'll be okay with you ignoring this one once you understand what it is we're doing. Let's look at example 9. Multiply -3 parentheses 5a plus 2. Does anyone would like a minute to copy that one down before I work it out? Or can I start it? Would anyone like a minute to copy it? Or can I start? All right, I'm gonna go ahead and get it started. So this is also gonna be distributed, but it's not always gonna be direct. It's not gonna tell you use distributive property. It's sometimes just gonna tell you multiply because distributive property is multiplication, ladies and gentlemen. That's why we did this other example here. Here you're distributing the 5, but it's only one term inside the parentheses. But in the next examples here, there's multiple terms. So let me go ahead and set this up. So I'm going to write -3 parentheses 5a plus 2. I'm going to draw my arrows to denote that I'm going to distribute these terms. So it's going to be -3 times 5a. That's my first term. Plus -3 times 2. Now, if you want to use parentheses instead of the dot, you can do so. Like this means the same thing, y'all. Like you don't have to do the dot. It's up to you. Whatever is, if the negative, if like the inside was a minus sign, I would then do parentheses so you don't think it's minus a number, you know, just be smart about which symbols you use. So -3 times 5a, a negative times a positive is negative. 3 times 5 is 15, and do not forget the a because the a is right there. Then we have plus -3 times 2. Well, we know the plus is down here. -3 times 2, well, that's -6. Well, remember what I said when we have a plus a negative, what happens when we combine these two plus a negative, you use this chart over here that I gave you. A positive negative is a minus sign. So I'm going to go ahead and combine those and get -15a minus 6. I want you to get comfortable simplifying these operations into one. So we don't have plus negative, you know, it's just one sign there. What questions do we have so far on examples 8 or 9? Excellent, guys. All right, last example, we're on 10 on the slide. So we're going to do 8 parentheses x minus 4. This distribute the 8. So it's going to be equals 8 times x minus 8 times 4. Notice how I just bring the sign down. Like I don't even think too much about it. I'm not just putting times 8 next to the x and times 8 to the 4. Now let's combine. 8 times x we both know is 8x, or we all know. 8 times 4 is 32. Bring down the minus, so it'll be minus 32. And we're done. Does anyone have any questions or need any time to copy these slides down, this slide down before I put on the next slide, the practice problems? You are seeing the distributive property in action. We're doing all these components, guys, because in just a few moments, we're going to be combining this property, the distributive, with combining like terms And then we're gonna do those properties, and then use those to solve equations. So our math level is gonna be increasing as the lesson continues. So it's very, very, very important that you guys are following along and seeing the built up of the different skills that we're gonna be using this week or this semester. So last call, guys. Anyone still copying? All right. Here are the next 3 practice problems, guys. I'm gonna go ahead and give you guys about 5 minutes. Good luck. Or I'll give you 4 minutes, and you need more than 4, I'll add time. Good luck, everyone. All right, guys. So now that we're looking at the practice problems, I see some people put in the chat. Nice. So we have 8y plus 16 for 8. Yeah, 21a minus 15, and then 30 minus 6y. And Manuel and Carly both agree. Excellent, excellent, guys. Is there anyone that's getting stuck on any of the components from these practice problems? Because Sarah is correct on all 3, guys. If you did get all 3 solutions like Sarah, you did get all of them correct. Are there anyone that needs me to explain how to conduct or do these problems? Anyone need me to explain? All right. Are we safe to move forward, everyone? All right, let's keep going. So now notice how the problems get a little more complex now. Now we're going to distribute more than once. Now we're going to see how this goes. I'm going to go ahead and give you guys 1 minute to set up the first example on top, and then we'll only write as we finish each example, we'll start the next one and work on it. Okay, guys? Now these are still notes, so I'm going to be going over these. Now, if anyone wants to discuss with me, you can, or like help me solve it as we go. Your 1 minute to set up the first one starts now.
On the first one, will we do the negative 15 last?
In terms of combining, that is correct. Now, as you ask yourselves, guys, you got to ask yourselves, are we going to distribute the 2 to the negative 15? Yes or no? Why or why not? Remember, where do we distribute the number 2? Where? Inside the parentheses, outside, or everywhere? What are your thoughts?
Wouldn't
Remember,
it be inside the parentheses?
yes, that is correct. Because remember the property that we wrote down in our journal, it's only showing the things inside, right? So yeah, that's the one thing to remember, that the 2 does not go to the 15, y'all. So the 1 minute timer just went off, guys. So like someone just said earlier, it's only going to go to the parentheses. So draw your arrows into the parentheses only, leaving the 15 alone because it's not in the parentheses. So this part right here will be 2 times 3 plus 2 times 7x, bring down the minus 15. So now remember, you have to use PEMDAS to simplify. So there's no P, no more parentheses. So now there's no exponent. So now we're gonna multiply, divide from left to right. So what's 2 times 3? That's
6.
2 times 7x.
14.
14 what?
Y.
You sure?
Well, X. Sorry.
No, you're good. Minus 15. Now, can I box, or can I simplify further? Are there any like terms?
The 6 and negative 15.
That's correct. If you owe the bank 15 and you can give them 6, how much are you going to owe them? Anyone?
Can you say that again?
If you have $6 in your account and you spent 15, what are you going to have left over in the bank? Are you going to have money, or you're going to owe money?
Oh, money.
Yep, we're going to owe $9 and we're done. So does everyone see how we apply distribution first and then combine like terms? That is going to be the rule of thumb as we move forward in the lesson, okay? Now look at the second example, -2 parentheses x minus 5 plus 4 parentheses 2x plus 2. How many times are we going to apply the distributive property? Do y'all see here?
Twice.
Twice. We're going to multiply the -2 to these right here. Then we're going to distribute the +4 to these two here. Everyone see that component. Now we're going to write out the step of multiplying so we know what we're doing. So the first line is going to be -2 times x, -2 times -5. So 5 is minus. And then we're going to have +4 times 2x plus 4 times 2. Notice how I had to put parentheses around the -5 just because it's x minus 5 and we're multiplying with the -2. So this is the minus from here, it's right here. All right. Notice how some it's better to use the dot, some it's better to use parentheses. You can be consistent and use the same property for all. If you're gonna do the dot, make sure you don't get confused that it's a minus of 5. You know, that's why I put parentheses here because it would look like -2 minus 5, and you don't want to confuse yourself. So you want to determine what symbol works best for you. Now let's simplify. -2 times x, that's -2x. -2 times -5, two negatives make a positive, plus 10. 4 times 2x is a positive 8x. 4 times 2 is a positive 8. Now we did the distribution, so now we combine like terms. We can combine -2x with positive 8x, and then we can combine 10 with a plus 8. So let's combine. If you owe someone 2 x's and you have 8 on your person, how much do you have left once you've given them the 2 that you owe? You have 6. 10 plus 8, you have $10 and found 8 more. Now you have 18 and we are done. Any questions so far for the first two examples? All right, the third one gets a little tricky because we have negative parentheses x plus 4 plus 5x plus 16. Can anyone tell me what number is next to this minus sign that none of us are able to see? But
One.
yes, that is correct. The 1 is there. All right, so let's go ahead and write it. It's very important when you have a minus by itself. Always add the -1 right there. Just include it in there. That way you know, hey, I know that's there. I can't ignore that. And now I'm gonna distribute that to the terms inside the parentheses. Now let me give you a little fun fact about mathematics, guys. When we multiply or divide by a -1, guys, when we do that, we're gonna go ahead and change the signs. If we multiply -1 to a positive number, it becomes negative. When we multiply the -1 to an x, it becomes -x. The signs just change. So -1 times x. So we're gonna do -1 times x plus -1 times 4. Oh. And then bring down the plus 5x plus 16. Well, -1 times x is just -x. -1 times 4 is just -4 or -4. Bring down the plus 5x and the plus 16. And now you just combine your like terms. You can combine -x with 5x. And then we can combine -4 with plus 16. So when we combine those guys, what do we get? What's -x plus 5x? I believe that's 4x. -4 plus 16 is 12. And we are done. Do we have any questions on these examples on applying distributive property and combining like terms? Any questions at all, or comments or concerns? All right, let's go ahead and move on, guys. Here are the next set of practice problem, guys. I'm gonna go ahead and give you guys I'll give you 5 minutes on this one. All right, good luck, everyone. Uh, 10y minus 23 for the first one. Anyone agree or disagree? Anyone agree or disagree for the first one?
Agree.
Excellent. Thank you.
Agree.
Same.
And then for the second one, Jean got 3x plus 22. Anyone agree or disagree?
Agree.
I heard one agree. Anyone else? Now for the last one, let me see real quick. Negative 7x, 10x, that's 3x plus. Yep. Okay, so 2 is good. Now the last one, he got 2y minus 13. Does anyone agree or disagree with 2y minus 13?
Agree.
Excellent. Anyone need any help on how to simplify these? Anyone need any assistance? Any questions on it?
On the last one, could you explain it?
Yes, of course, of course, of course. So look at the last one. So first we have to distribute the last, so the right here. And remember what I said when there's a minus sign, what number is invisible, y'all?
Is it 1?
It's a 1, a negative 1. So we're gonna distribute the negative 1 here. So then we're gonna get negative 1 times y plus negative 1 times 1 plus 3y minus 12. Well, negative 1 times y is just negative y. Negative 1 times 1 is negative 1. So it'll be plus negative 1 plus 3y minus 12. Well, remember, we know that a plus a negative, that's just like a minus sign. So it'll be negative y minus 1 plus 3y minus 12. And we have to combine our like terms. So we can combine negative y with 3y and gives us what? You owe me 1 and you have 3. So you're going to have 2 left over. So 2y. And then negative 1 minus 12. You owe me $1 and you're like, Pacheco, I need 12 more so I can get lunch. Well, I'm like, you already owe me $1. So now you're going to owe me how much? You're going to tell me 13 and we are done. Any questions on the steps that we just did, guys? Any questions?
Thank
So
you.
it would be the same way on 2, kind of.
With the negative 7?
Yes.
Yes. Yes. And I remember I remember what I meant when I said there's a negative, whenever there's a negative number, the sign changes. So y was positive and it became what? Negative. This plus 1 was positive, but when we multiply by negative, it became what? Negative. So when we multiply the negative 7, just remember the sign changes, but you're multiplying with the 7 too. So negative 7 times x right here, these two gives you negative 7x because the x becomes negative and we're multiplying the 7 there. Now look at the negative 1. We're multiplying the negative 7 here. So two negatives make a what? Positive. 7 times 1 is just 7. So that's what this distribution does. How a negative works out. Does that make sense?
Yes.
Excellent. I'm loving your questions, guys. All right. And we finished our first lesson, guys. Woo! Now we're starting the 3.2 today. All right. I'm gonna go ahead and give you guys about a minute or a minute and a half to set up the title and example 1, guys. Okay. A minute and a half starting now.
All right, so in 3.2, ladies and gentlemen, we're gonna be solving equations and we're gonna review how the addition and multiplication properties were. You do have them in your notebook already. Every time you get a property, guys, I highly recommend you guys putting it in a note card. The end definitions, that helps too. But mainly properties, guys, just because these properties is kind of where our basis is on how we do these steps here. So we're gonna solve equations, but now we have extra steps to do now. I'm gonna drop down a line on the equal sign. Y minus 5 is there, but look over here to the right side. We have -2, -2 minus 6. Now, I want you to remember, we know an equation is the same thing as expression equals expression, correct? Remember that definition from last week? We know that much. But remember, expressions can be simplified. So look at the left side, y minus 5, and then the right side, -2 minus 6. Can I combine any of the sides with any like terms? Like, can I combine y with 5? Or can I combine -2 with -6? What do you guys think?
Yes.
-2 with 6.
-2 with 6.
So when we combine -2 and 6, can you guys hear me?
Yes.
Okay, so you -2 minus 6 is just -8. You borrowed $2 and you borrowed 6 more, and now you owe me 8. So now we have y minus 5 equals -8. Now we can manipulate the equation on the left side to get y by itself. Now remember, to manipulate equations, we have to do the opposite operation. So on the left side, we have y minus 5. So can anyone tell me what the opposite of -5 would be in mathematics?
+5.
+5. So we're gonna add 5. Now remember, what we do to one side, we have to do to the other side. So the 5s are gonna zero out. So I drew a 0, bring down the y, and now simplify the right side. -8 plus 5. Hey, you guys owe me $8 and you paid me a 5. How much do you still owe me?
-3.
-3. Now we have this component, but let's check, right? We don't know if this is right. So we're gonna go ahead and check it out by plugging it in. So then we're gonna get -3 minus 5 is equal to question mark -2 minus 6. So we plugged it into the original equation, guys. This one was y is, right? So we know the right side simplifies to -8 because we already did it over here in the equation. Now let's simplify the left side. -3 minus 5. You owe me $3 and you borrow 5 more, so now you owe me 8. -8 does equal -8. It's true. So therefore, this is the solution and we're done. What questions do we have before you jump into practice 1, y'all? Any questions? Notice how I didn't combine the -5 with the -8. I didn't just do -13 because you have to, whenever you cannot combine expression, like something from the right side to the left side at all. You can't combine it. That equal sign is like a barrier. So if you want to move one thing from the other, we do the opposite operation. But -2, -6, we didn't move anything. We just combined these two and got the -8. That's a difference, okay? So, and you'll get the gist of it from more practice. I'm gonna go ahead and give you guys about 1 minute to do the practice, a minute and a half to do the practice 1. Let's see how you guys do. All right, good luck. Find the solution and then I want you to check it. Good luck. Excellent. Gene already got a solution. If anyone wants to agree with him or disagree, awesome, Kayla. Good to know. Everyone else chime in on what your thoughts are. All right, guys. So -8. So Kayla agrees. Anyone else agree or disagree with Gene? All right. If you got a -8 for practice 1, you got it correct, ladies and gentlemen. -8 is the solution for this equation. Any questions before we move on to the next slide? All right. So now we have example 2. We have a multiple of equations to solve. So I'm gonna go ahead and give you guys about a minute to set up the first equation, and then we'll work our way through each one. Okay, guys? I'm gonna give you 1 minute. Look at the first example, 3y minus 7y equals 12. So draw a line down the equal sign. Is there any side of the equation that we can simplify or combine any like terms, ladies and gentlemen? Is there anywhere we can combine things?
Wouldn't
Would
it be
it-
3 and 7?
Yeah, the 3 and the 7, they're both y terms. We can combine 3y minus 7y. Well, you have 3 and you owe 7. So once you give those 3, you're still going to owe a total of 4 still. Oh, crap. But that's still going to combine them. So it's going to be -4y. And then bring down the 12. Now there's nothing we can combine on the left nor the right. So now we can solve. What operation is happening between the -4 and the y? They're being what? Multiply. Can someone tell me what the opposite of multiplying -4 is?
Division.
Yes, we're gonna divide -4. And what we do to one side, we do to the other. The -4s are gonna 1 out. We're gonna make a 1 here. So then we get 1y, which is just y. And then a positive divided by a negative is a negative. And 12 divided by 4 is -3. So we get a -3 for y. Now we're not done though, because I did show you how to check your work. So you're gonna do check. Now I'm not gonna check on every solution because I know what I'm doing, but when you start to work on your practice problems, you want to check, because what if you don't have me? What about you weren't in class and you're by yourself? You want to check if you can get this. Now remember, the question mark is always on the first step, because do we know if -3 is a solution? No, that's what we're checking. 3 times -3, y'all. 3 times -3 is a -9. Can someone tell me what a -7 times a -3 is? Do we know what two negatives make?
+21.
That's correct. +21. You have $21, but you already owe 9 to the bank. So once you put your 21, you're gonna have 12 left. Does 12 equal 12? True or false?
True.
So therefore, this is a solution. All right, let's go ahead and look at, oh crap, what the hell was that? Okay, my apologies, y'all. All right, let's get back into it. So then let's draw look at the second example. Z divided by -4 is equal to 11 minus 5. Now, when you draw the line down the equal sign, are there any side that we can simplify anything or combine anything? Any like terms?
11 minus 5.
And what do you get when you subtract those two? 11 minus 5. I think that's 6, correct? Now we do z divided by -4. Now we want to get z by itself because we're no longer combining anything. So can anyone tell me what the step would be to get z by itself? How do we get rid of that dividing -4?
Multiply by -4.
That is correct. So we do times -4 and do parentheses -4 on the right side. These -4s are going to become a 1. So then we get z by itself now. 6 times -4 is a -24. Box your answer. Now we're not done, so we want to double check. So we're going to do check. So then we get -24 divided by -4 is equal to question mark 11 minus 5. Well, we know 11 minus 5 was 6, right? We finished that part already. Two negatives we know make a positive. 24 divided by 4 is 6. That's true. So therefore, this is the solution. So far, so good, ladies and gentlemen. So now let's go ahead and look at the last equation here. So let's go ahead and drop our line down the equal sign. I'm sorry, I didn't like the line I drew. Line down the equal sign. Still don't like it, but whatever. Better than before. All right. Are there any sides that we can combine like terms? Is there anything in the left side we can combine? Anything in the right side? Look at it carefully.
5x and -4x.
When we combine 5x minus 4x, how many x's do we have left?
Just 1x.
Just 1x, right? And we don't have to really write the 1, so we can just write x. Bring down the +2. Can I combine anything on the right side?
Yes, 7 minus 19.
Yeah, what's 7 minus 19? You owe the bank 19 and you're like, here's $7, bank. What do you now owe them?
12.
Yeah, you owe them
-12.
-12. Now to get x by itself, to solve the equation, ladies and gentlemen, what do we do to get x by itself?
Subtract the 2.
Subtract the 2. And what we do to one side, we do to the
other.
So then bring down the x. Hey, you owe me 12 and you're like, Pacheco, I need 2 more to get a Coke. How much do you now owe me?
14.
-14. Now let's go ahead and remember to always check. So then you get check. So then you get 5 parentheses -14 plus 2 minus 4 parentheses -14 equals 7 minus 19 question mark. We know 7 minus 19 is -12. Now let's do the right to the left side. 5 times -14. I think that's -70. Plus 2. -4 times -14. 2 negatives make a positive. 4 times 4 is 16. Carry the 1. It's 56. Add and subtract from left to right. We get -68 plus 56. So we get -12 equals -12, which is true. This is correct. Are y'all seeing how beneficial it is to be able to check our solutions? And the crazy thing about this concept, guys, is this what we're doing now works for the difficult equations that we'll be learning this semester. With quadratics, it would work with quadratics, cubics, polynomials. It would work with exponentials, logarithms. This process works. It's a way to keep yourself in check to avoid making any mistakes. All right. Are there any questions on any of the steps we took in these examples? Any questions? All right. Let's go ahead and begin. So you're gonna have a practice problem, guys. I'm gonna give y'all 5 minutes on these to see how you guys do, and then and I'll give y'all more time if you need more time. Good luck, everyone. So +1, +1. These zeros out. So then we get y equals 19 plus 1, which is 20. And we're done. Now remember, when you're doing this on the assignments on your own, make sure you're checking your answers. So that way you know for sure that that's the correct solution. All right. Does that make sense to everyone who asked me questions for these practice sets? Does everyone feel better about them?
Yes, sir.
Excellent, excellent. All right. Now, example, now it's gonna get just, it's still getting a little more, it's the same concept, but we're just adding more properties. You see in this one, so this is A and this is gonna be B. You see on the B example, we have distribution now as well. So it's gonna add more properties to the equations as we progress in this class, guys. So I'm gonna give you guys a minute to set this up into your notebook before we jump in, okay? 1 minute. Good luck, everyone, and then we'll get started. All right, guys, let's look at example A. So remember, the first habit you want to get into is always drawing the line down the equal sign. When we do that, we look at each expression on each side to see, can we combine or simplify anything? Look at the left side, 8x minus 9x. Can we simplify anything there?
Yes, the 8x and 9x.
When we combine those two, what's your result gonna be?
Negative X.
Negative x, that's correct. Now look at the right side. Is there anything that we can combine on the right side?
Would it be 12 and 17?
Yeah, we can combine those two, right? Because they're both constants, right? So what's 12 minus 17?
I got -5.
Negative 5. That is correct. Now, do we have x by itself?
No.
No. What's in front of it that we don't really see, but we know it's there?
The
One.
-1.
The -1. Yeah, all agree that it's a negative, right? So then the opposite of multiplying -1 is we're gonna divide by -1. What we do to one side, we do to the other. So this becomes a 1. So this is just x now. And two negatives make a what?
+5.
Positive 5. And now remember, you can always check your work. Check. So it'll be 8 parentheses 5 minus 9 parentheses 5 equals question mark 12 minus 17. We know 12 minus 17 is -5. 8 times 5 is 40 minus 45, which is -5 equals -5. It's true. So this is a solution. So then that's A. All right, let's take a look at B, class. Now, if you're, so remember, draw the line down the equal sign first. So when you do that, now what property can we do on the left side to simplify? What is it called? I want you to know the name of the property and tell me.
Distribute.
Distribute. So we're gonna go ahead and draw our arrows to show that we're gonna distribute. And we're gonna multiply, right? We're gonna multiply 3 times 3x minus 3 times 5. Well, let's simplify that. 3 times 3x is
9x.
good. Minus 3 times 5, which is 15. And just bring down the 10x. Now, there's a lot of different steps we can take to get x alone, guys. So how would y'all do this, guys? Remember, we want x's on one side, numbers on the other side. So how would
I subtracted 9x.
you subtracted 9x? Why did you subtract 9x? Why?
Well, because the x is already on the right side. So to get 15 or -15 alone, I just subtracted the 9x. Moved it
Excellent.
to the other side.
And we subtracted it also, just to let everyone know, 9x is originally positive, right? And the opposite of positive is subtracting. So this becomes 0, bring down the minus 15. And what's 10x take away 9x?
X.
X. Now, if you don't like this order, you can just switch it up. X equals negative 15 and you're done. Now you can always check to make sure you're on the right track. So then when we check, plug it into the original. So then it'll be 3 parentheses, 3 parentheses negative 15 minus 5 parentheses equals 10 parentheses negative 15 question mark. And we just simplify that to make sure we get a true statement. 10 times negative 15, that's negative 150. Now we have 3 times negative 15 here. So 3 times negative 15 is negative 45 minus 5. Remember, we used PEMDAS to simplify, so we did that. Now we're going to do this. That gives us negative 45 minus 5 is negative 50. And then we multiply the 3 and negative 50 and get negative 150 equals negative 150, which is true. So this is correct. Now, what questions does anyone have so far on the steps that we're doing or on the checking? Anyone have any questions, comments, or concerns? All right, let's see how you guys do now when y'all are asked to do this on your own. Here are these two practice problems, guys. I'm gonna go ahead and give you guys 4 minutes. Let's see how you guys do. Good luck. All right, guys. So Gene was able to share his answers. Thank you, sir. Y equals 14 and then X equals -4. Does anyone agree or disagree with Gene?
Can you do the last one? I'm kind of like stumped on that one.
No worries. I'll do that real quick. Anyone need me to try number 1 before I do the second one for it? All right, let's try the second one. All right, remember, run me through the process. So first we draw the line on the equal sign. Can we simplify the left side any further?
No.
So bring it down. Can I simplify the right side? If so, what property can we use to simplify this, guys? What property is this called?
Pam.
Not PEMDAS. It starts with the letter D. We're gonna distribute, okay? So then when we distribute, what operation is gonna happen with the 4 and 3x, y'all? What operation is that? So be 4 times 3x minus 4 times 1. So it'll be 4 times 3x equals to 12x, and then minus 4 times 1, which is -4, and bring down the 13x. Now remember, we want to get x's on one side, guys. So how do we, if 13x is already on the left side and 4 is already here, let's move this 12x. How do we move a positive 12x to the other side? The opposite of positive 12x is negative 12x or minus. What we do to one side, we do to the other. This becomes 0, and now we have -4 on the right side to bring down. And subtract these two. What's 13 take away 12? Well, that's 1x, which is just x. And we're done. Does these steps make sense now? Do you see what we did?
Yes.
What part were you stumped on? Was it the distribution part on the right side or?
Yes.
Okay. Remember distributive is whenever there's a number and or letter with parentheses and stuff inside the parentheses, okay? Now remember that 3x minus 1, we cannot simplify this using PEMDAS because they're not like terms. Does everyone remember like terms? You can only combine x's with x's, numbers with numbers, letters with letters, y's with y's. Any other questions on these practice problems before we move forward, guys? Any questions whatsoever? Comments or concerns? All right, let's keep going. So you see how it's getting a little more intense now, right? That the steps are getting more intense. So I'm going to give you guys a minute to set up this this example in your notebook, 1 minute, and then we'll get started. Then there's 2 examples here. There's example A and example B. Example A, example B. All right, let's go ahead and look at A now. All right, so A, 2x minus 6 equals 18. So we have 2x minus 6 equals 18. First, we see, can we combine any like terms on either side of the equation, right? On the left side, 2x minus 6, can we combine 2x and 6, guys? Yes or no?
No.
Good. And 18 is by itself already. So now we're gonna do multiple steps to get X alone. So if we want to get X alone, we have to mess with this 6 first. So what's the opposite of -6, y'all?
Addition, add.
Addition. So we're gonna add 6 on both sides. So this becomes 0. Bring down the 2x first and do 18 plus 6, which is 24. Is X alone yet? It's not, right? It has a 2 next to it. What operation, if anyone can tell me, is going on with the 2 and the X, guys? What's happening here?
Multiply.
Multiply. And what's the opposite of multiply?
Divide.
So we're going to divide both sides by 2. So then this becomes a 1, right? So then we bring down the X. 24 divided by 2 is 12, and we're done. Now we're not fully done because we don't know if this is the correct answer, right? We don't know. So we check by plugging into the original. So it'll be 2 parentheses 12 minus 6 equals 18 with the parentheses on question mark on top. 2 times 12 is 24 minus 6. 24 minus 6 is 18 equals 18, which is true. So this is the solution for the equation. Does everyone follow the process of the solving and the checking? All right, let's look at B. Draw the line down the equal sign. Can I combine anything on the left side, or do I just bring it down? Look at it carefully.
You can combine the 2
minus 6. And when you combine that, what do you get? You have $2, but you spend 6 at the store. What do you owe the bank now? 2 minus 6. They take the 2 that you have. -4. That is correct. And now remember, guys, I don't need you to do it in your head. You can use a calculator if you have to. Now look at the right side. What property can I do to help simplify the right side better? What is that property going to be called?
Distribute.
We're going to distribute what value?
-5 to x and -5 to 4.
That's correct. So -5 times x is what, guys? What's -5 times x?
-5x.
Good. I'm gonna skip the step that I do the dot now because I need you. I hope at this point everyone understands this multiplication, correct? So
Yes,
then
sir.
we get -5 times a +4. What's a -5 times a +4?
-20.
-20, and bring down the -39. Now, do we have any like terms on the right side that we can combine?
-20 minus 39.
And when we combine those two, what do we get? You owe me 20 and you borrow 39 more.
-59.
-59. Is everyone with me, or does anyone have any questions so far of what we've done? All right, now we want to get X alone. So what do we have to move from the right side to start getting the X alone?
Add 59.
Add 59, because it's the opposite of minus. What we do to one side, we do to the other. So that becomes 0. Bring down the -5x, y'all. You owe the bank $4, but your parents love you and they gave you 59 bucks to put in your account. When you put those 59 in, what's your balance left over once they take the 4 that you owe?
+55.
+55. Now, do we have X alone yet?
No.
So how do we get rid of that -5?
Divided.
We have to divide it. And what we do to one side, we do to the other. So that becomes a 1. So we get X on the right side. What's 55 divided by -5, y'all?
-11.
-11. So then our solution is X equals -11. Now, when you're checking this, y'all, I don't have a lot of space, so I'm gonna just plug it in up here. The checking, you just write the word check, right? And then just plug it in. So you get 2 minus 6 question mark on the equal sign, -5 parentheses, -11 plus 4 minus 39. Oh. Plus 4 parentheses minus 39. So we know 2 minus 6 is -4. Then the right side, so you do negative 11 plus 4, you do parentheses first, right? So that's -7. So -7 times -5 is positive 35 minus 39, which is -4. So we get -4 equals -4, which is true. So this is the solution. My apologies for the disorganized on the B, just didn't anticipate the space. Any questions on any of the steps that we did, guys? Now, if you already know and you're comfortable with distribution, knowing that it's multiplying, you don't have to notice I didn't write that step that I normally do. I didn't do -5 times X, and I didn't do -5 times 4. Like I didn't do any of that. So I skipped this step now. So I want you to know that it's okay to skip that step if you're comfortable knowing that distribution means multiplication to everything inside the parentheses. All right, guys. So let's go ahead and look at your practice problems, guys. This is you have 2 of them right here, A and B. I'm gonna go ahead and give you guys 4 minutes on these to see how you guys do. Good luck, okay? Follow the notes if you have to. Good luck. All right. Does anyone need more time to work on these practice problems or have any questions, comments, or concerns?
I'm still working on B.
All right, let me go ahead and add, would you like a minute or two?
2.
I got you. All right, good luck, everyone.
Can we go over A now?
Yes, I'll go over A while she works on B. All right, let's look at A, everyone. So let's go ahead and draw the line on the equal sign. Now, there's nothing we can combine or simplify on the left and right side, right? So we just gotta solve for Y now. So what do we move first to get 5Y by itself? The 2, right? What's the opposite of +2?
-2.
Yep, -2 becomes 0. So then we get 5Y equals 15. Now Y is still not by itself. So what do we do to get the Y by itself? What operation?
Divide.
Divide. We're gonna divide both sides by 5 because it's next to the Y. This becomes a 1, which is Y. And how many 5s go into 15? 3.
Mhm.
And we're done. Don't forget to check, because whatever you don't know if you're right, you want to make sure you get the right answer if it's a test. So you get 5 parentheses 3 plus 2 equals 17, question mark. 5 times 3 is 15 plus 2. 15 plus 2 is 17, which is true. So this is the solution. Any questions on the first one on A?
No.
All right, guys. Let's look at, anyone need me to look at B or I know Sarah is still working on it. Anyone need any help or want to talk about it? Anyone not get 3 and wants to talk about the mistake they made? Because we want to, the biggest thing about learning, not just in mathematics, but learning in general, is you want to kind of recap your mistakes that you're making, be like, oh, that does not work out. I should not do that. Let me avoid that. It's like similar to burning your hand, touching the comal. You'd be like, I'm never going to touch that again. That's kind of like the struggling of learning. It's you want to struggle so you don't want to do that again in the future. So let's talk about, anyone need me to talk about B? Or am I good to move forward?
Can we talk about it, please?
Yeah, of course, of course. Now let's go ahead and draw the line down the equal sign. Now let's look at the left side. How can we simplify the left side further? What property must we use to be able to simplify the left side?
Distribute.
That is correct. So we're going to distribute the -4 to these two. What's negative? Now, why do we not distribute the -4 to the 60? What's the reasoning? Or can we? Like, talk to me, guys. Can we distribute the -4 to the 60 or should we not? Why or why not?
No,
Why not?
because of the parentheses.
That is, what about the parentheses?
You're supposed to only multiply the numbers inside the parentheses.
That's correct. That's correct. Thank you for sharing. So we're now, like he said, we're gonna multiply. Can someone tell me what -4 times X is?
Negative
-4x.
-4x. Everyone with me on that step. Now we're gonna do the second arrow, -4 times a +2. What's the -4 times a +2?
-8.
-8. Bring down the -60. Is there anything else I can combine on this left side after I distribute?
The -8 minus 60.
Yep, you owe me $8 and you borrow 60 more. So now how much do you owe me once you add up both balances?
-68.
Correct. Now let's look at the right side. 2 minus 10. You have $2 and you spend 10 at the store. How much do you owe your bank?
-8.
1 second, guys. My doctor's calling. Hold on. Hello, hello, testing. Can you hear me?
Yep.
All right, sorry about that, guys. So now we're at this component. Now we have to just solve this equation now. So what would y'all move first, guys? If you're solving this equation for x, what do you move first from the left side that you think?
Add 68.
Add 68. What we do to one side, we do to the other. This becomes 0. Bring down the negative 4x. You owe me $8, guys, but your parents love you and they gave you 68, or you worked for it, got 68 bucks. When you put the 68 into your bank, they take the 8. How much do you have for yourself? What's negative 8 plus 68?
Positive 60.
Positive 60. Now, x is not alone yet. So what's the next step that you're going to do?
Would you add 4?
You should. Now, remember the operation. What's happening with negative 4 and x?
Multiply?
They're being multiplied. And remember, to manipulate equations, we have to do the opposite. So what is the opposite?
Divide.
Divide. Good. Do you see why it's division and not addition? We will only do addition if it was like this, x minus 4. Then we will add the 4 because it's being subtracted. But that negative 4 isn't being subtracted, it's being multiplied. And what we do to one side, we do to the other. This becomes a 1. And now positive divided by a negative is negative, and there's 15 fours and 60. So 60 divided by negative 4 is negative 15. Does everyone see the flow of the steps on how we simplify and how we manipulate it to get x alone? And then you'll check it by plugging it in. You can just do it real quick. Negative 15 plus 2. Negative 15 plus 2 is negative 13. Negative 13 times negative 4 is positive 52. 52 minus 60 is negative 8. 2 minus 10 is negative 8. So it does work out. But I'm not going to put the time into the checking just because I don't have the space for it. But y'all can always do it yourself. Are there any questions on the checking part? Or does anyone need me to do it so you can see it for yourself? I don't mind either way, guys. It's just up to you. Are we okay with moving forward, guys? For the ones who asked me to do the problems, everyone feel good about it? You really want now. I remember what I said in the beginning of class, guys. Lecture is it is a great resource, but the main learning happens on your own when you're studying and working on the practice problems from the assignments that I'll post later. Let's go ahead and move on. Now we're gonna recall. Remember translating word phrases into expressions. Remember the different operations and what the words mean. Now you don't have to write this again just because we already have this in our notebook, but this is another resource that I highly recommend writing in an index card. So because you're gonna be doing this often, you're gonna be writing phrases from into expressions from just reading something. So you need to know what these words, what operations it means. So you don't have to do it on an index card today, but I highly recommend having it. And it's gonna be one of those resources that you have when you're working on tests or homework assignments. Let me pull up this phrase. Oh, this problem says difference. Oh, it's subtraction. Cool. And eventually, after utilizing that resource multiple times, you're not gonna need to do that again. So you don't have to rewrite that box. You don't have to rewrite the top part, guys. We already did that in our notebook. So you can start off with example 9. But I did put it back up there to remind you, hey, we did this earlier. Guess what? We're using it now. So I'm gonna give you guys about 2 minutes to set up example 9 in your notebook. Because I would hate for you guys to write it again in the notebook and then a note card. So unless you want to do it, up to you. But just I'm only giving you 2 minutes for writing out the example 9. And if you want to try to get started on these, I recommend writing them down first. Don't just write the answers because these notes are meant for you to look over again as you study and work on the assignments. That's very key. I don't just make my notes to torture you. I make them because I know you're going to see them in your assignments and whatnot. All right, let's look at example 9A. I'm gonna do one at a time. So a number increased by -5. Now write each phrase as an algebraic expression. Use X to represent a number. A number increased by -5. So what do we use for the phrase a number? A number is use X. So we're gonna use X. Increased by is addition, so it'd be plus. And it's increased by what? It's being increased by -5. So it's X plus -5. But look, we have two operations here. How can we condense these two into one? X plus -5 is the same as what expression, guys? Can anyone tell me what a plus and negative do? What operation it simplifies to?
Positive.
A negative. So a negative. So it'll be X minus 5. So these two are the same thing, guys. All right. These two mean the same thing. All right. B. B is the product of -7 and a number. So -7 and a number, and it's the product. So what operation is product? Is multiplication. So it'll be -7 parentheses X. But we know that's -7 times X, which is the same thing as or -7X. Either or will be correct. C. A number less 20. A number less 20. So number less 20, I would say it'll be X minus 20. So saying a number first, right? So that's X. Less is minus 20. It's over here under subtraction is right here, less. So look at D, the quotient of -18 and a number. So what operation is quotient, y'all?
Division.
So what should be on top and what should be on bottom?
I think it's the X and then the bottom is -90, 80.
Ah, you got it reversed. You had to go in order. Notice how I did product. I did 7 and then X, -7X. So it's the same thing here. It's going to be -18 divided by X, or as a fraction, -18 divided by X. Is the order of the numbers it has. And then we have E. E is a number subtracted from -2. A number subtracted from -2. So what should go first, X or -2? If you're subtracting,
X.
look at the way it's worded.
Oh, yeah.
-2.
Yeah, and then minus X. Does everyone see that? Does anyone have any questions on the way we wrote these expressions, guys? Any questions, comments, or concerns? Okay, because it's very important that you guys be able to do this. I'm gonna go ahead and anyone need more time to copy this down before I pull up the practice problems. All right, no questions, guys. All right, let's see how you guys do on this practice problem. Good luck. I'm gonna give you guys 3 minutes, and if I need more than 3, I'll add more to it. Good luck, everyone. 3 minutes starts now. All right, guys. Does anyone have any questions on these practice problems or would like to share their answers for each one to see if people got the same thing? You start with A. What did someone get for A? And I don't want to code call. I don't want to say someone's name and put them on the spot. So I'm just gonna leave the participation on you guys every class period. Up to you how you want to participate. And the sum of -3 and a number, guys. Did anyone get something for that?
-3 plus x.
All right. Does anyone agree or disagree with this solution?
I agree.
You are correct. This is the correct form. Next question. The next one. -5 decreased by a number.
-5 minus x.
Anyone
Agree.
agree or disagree? Okay, we have an agree. All right, you guys are both correct so far. Anyone want to go with C?
3 times x or 3x.
Good. So 3x or 3 times x, either or. Good. What about D? Did anyone want to share for D?
83 minus x.
83 minus x. Does anyone agree or disagree?
Agree.
Excellent, excellent. And I mean, that is correct. These two are correct. What about the last one? Quotient of a number and -4.
X divided by -4.
That's correct. correct. All right, cool. Anyone have any comments, questions, or concerns, guys, with this practice problem? All right, guys. So we have example 10.
I was just copying really quick the last one.
Oh, my apologies. Go ahead.
That's okay, thank you.
Let me know when you're good.
Okay, I'm good.
All right. Now we have example 10, but now they're adding more steps to it. It's not just one operation happening. There's the multiple things now. So I'm gonna give you guys a minute to set or 2 minutes to set up example 10, guys, and then we'll get into it. Okay, 2 minutes. All right, let's take a look at example 10a. So we're gonna write each phrase in an algebraic expression where we let x be an unknown number. All right, guys, I know it's been a long class day, but we're getting a lot of stuff done to help us out for the test this week. Write each phrase as an algebraic expression. Let x be the unknown number. So twice a number increased by -9. So twice the number. So what's twice the number? So the number's x, right? But when we twice it, what operation are we doing to? Are we adding 2 to, or are we multiplying it by 2?
Right?
Multiply.
Yeah, come on. So we're getting 2 times x. Everyone agree with that, right? That twice the number is 2x. So now we're gonna increase it. So what operation is increased by? Add by -9. But remember, we have a plus, a negative. So what operation do these simplify to? It's the same thing as 2x minus 9. All right, let's look at B. 3 times the difference of a number and 11. 3 times the difference of a number in 11. So if we're doing the difference of a number in 11, what operation is happening between a number and 11 for the difference?
Subtraction.
Being subtracted. So it's this 3 times the difference of x minus 11. Now let's look at C. The quotient of 5 times a number and 17. So we know quotient is division. So we're gonna have division here. And we're gonna of what? 5 times a number that goes on the left side. What's 5 times a number?
5x.
Good. And what? 17, which is the same thing as 5x over 17. These two are the same thing. Any questions on how we combine multiple operations to make these expressions? Anyone lost with one of these examples that I did? Anyone still writing this down before I give you the last set of practice problems? I believe this is the towards the end of the lesson. Yeah, and this is the last example. So we're gonna do one set of practice and we're done with 3.2. All right, no questions and no one's writing. All right, here's your last practice problems, guys. I'm gonna give you out about 3 minutes to work through these. Good luck, everyone. All right, anyone want to tell me what they got for practice 10A? Either in the chat or you can unmute yourself and let me know. So it's the product of 5 and a number decreased by 25.
For A, I got 5x minus 25.
That is correct. Good job. Anyone anyone got something different? Okay, cool. I'm hoping the silence means other people got the same thing. Anyone want to share what they got for B? Twice the sum of a number and 3. Twice the sum of a number and 3. Anyone would like to share what they got?
2x plus 3.
I heard 2x plus 3. Does anyone agree or disagree?
I agree.
Okay. So I want you to break it down. It says twice of the what? The sum. This is twice a what? That's just saying twice a number, right? Is twice the number the same as twice the sum? What are we twicing, guys? We're twicing the sum between what?
Is it 2 plus x?
So I heard 2 plus x. So 2 plus x, this is saying the sum of 2 and x. This is what this is saying. The expression 2 plus x is sum of 2 and x. So this would not work. And this one doesn't work. So be careful with the wording, guys. Let's look at this. Read it again. We want to twice the sum of a number and 3. So first we're going to twice. So twice is what operation, everyone?
Times.
Times. So it's going to be 2 times something, right? But what are we going to twice? The what?
The sum.
The sum of what? X plus 3, right? But how do I get the double of the whole sum though? If I just do 2x plus 3, I'm only twicing the x, but I want to twice the whole sum. So what
The
I missed
parentheses.
around the what?
The x and 3.
There you go. Does everyone see the difference from these two to this one?
Now I see it.
Good, 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 good. That's my biggest thing. As long as you see the connection at some point, because it's saying twice the sum. This is once we add it, then we can double it by multiplying. Does everyone see that? Okay, good, good, good. Let's look at C, the quotient of 39 and twice a number. So we know quotient, right? Anyone want to tell me what they got?
I put 39 divided by 2x. Okay.
Cool. Anyone agree or disagree with this? So whenever we get the quotient, the first number or symbol is going to be the first one. Everyone remember that, right? And then it's going to be of twice a number. And we know number is x, right? And when we twice it, we're multiplying it. So this is correct. But I do want you to just keep it on the fraction version because this is college now. And we don't really use this division symbol anymore. It's kind of obsolete in college. Now we can utilize it to write some stuff, but I want you to start focusing on the fraction notation of division. And you did it, guys. You finished 3.2 today. Now, what questions does anyone have for me on the 2 lessons we've established so far? Any questions, comments, or concerns? Now, I do apologize, guys. I did anticipate to give a break this morning, but I kind of just like dove in and kind of just got lost in the lessons. And my apologies on that. Yeah, it doesn't excuse the lack of a break. So on Wednesday, I promise you we will have a break. I did want to do a 3rd lesson today, 3.3, so that way we can do the review in class. But we have 36 minutes to go, and I would like to give you a break before your next court classes this afternoon or before you go to work, just because I didn't give you a break at all during today's lesson. But before we talk about the test and everything, are there any questions on the math that we did today? Any questions? Okay, So let me explain, let me remind everyone, because we did have some late arrivals. Today is census day, so today's the last day you can drop a course without it appearing on your transcript. I don't know how the money works of that aspect, but just know if you don't withdraw or drop any classes today, everything, if you drop after today, like tomorrow, Wednesday, or in the future, they will show up on your transcript. So just keep that in mind. I'm not saying that you have to drop, right? Uh, I do want to make it be known, guys, that not everyone is working on the assignments online. That our first test is this week. So this is what I'm gonna do, guys, because I've talked to other professors, and what they do is they do the test during class for 2 hours of class time. Um, I I I rather not do a third lesson today. I'd rather start this lesson on Wednesday because we have two more sections before we do the review. But I rather not. I'm not gonna do the review mandatory in class. Like if we have time on Wednesday after I'm done with 3.3 and 3.4, like if I'm done and I'm able to start the review. Now, how many of you guys would like access to the review already so you can work on the ones you can do from the lessons we've done? Would anyone like the review already so I can upload it on Canvas?
I
Yes?
would.
Yes? Okay. I will do that. I will upload. So this is what I'm gonna do today. So today I'm gonna upload the video on YouTube for lecture 3, and I'm gonna upload the unanswered, unworked review questions. I'm gonna put them on Canvas as an announcement or as an email. I'll place it as an email. Download the PDF and just get a separate sheet of paper or the second journal you're using your assignments on. You'll title it review, test 1 review, write down the instructions and the problems and just work through them using your notes. At this point in time, you should be able to get the majority of the review done already. And once we finish the last 2 lessons, that should finish up the rest of the review that you're working on. Um, Other than that, guys, I'm very proud of the participation we're getting from a few of you all. I appreciate the comments, the questions, and everything. I'm really enjoying being your professor this semester. It's brings a lot of joy to me. So now I'm decided that I'm not gonna do the test in class, and instead I'm gonna give you from Wednesday's class until Sunday to do all the homework assignments and test 1 by Sunday midnight. That way and now I am going to give the test a timer though. There will be a 2-hour timer. So I don't want you to start the exam until your homeworks are done and the review is done. Now the review is optional, guys, but I'm going to tell you right now, I made the review based on how the test looked. So I looked at the exam and I looked at the questions and I typed similar questions, just different numbers, different equations, and different letters, but it's the same concepts. So this is my word of advice. If you can do the review and you can do the homework assignments, then you would do just fine on the exams. Now remember, the average of your test grades will be half of your grade. Half of your grade. So the main component is you want to do excellent on the homeworks and on the tests. Now remember, attendance is 10% of your grade, everyone. So if you're coming in late and you're missing components or I marked you absent, I will change it when you come into class. But it is your responsibility to make up or find the lecture you miss via YouTube or the video lesson. Are there any questions about this week and anything we're doing this week in terms of the test review or the homework? Yes.
How do you access the YouTube video again?
I emailed you the links. I made an announcement that here are the links. I'll probably make a page on Canvas that says video lectures, and I'm gonna put each lecture link on there and just add to it as I upload them. I just look at the announcements. One of my first announcements has the links on that announcement, and you can just click on it and it'll open on YouTube. I recommend subscribing to my channel, so as I upload the new lectures, you'll get a notification that it's been uploaded, so that way you can revisit any lecture that you want. Great question.
Thank you.
Are there any other questions, comments, or concerns regarding this week's homeworks or tests or review or lessons? So Wednesday, we're gonna do 3.3 and 3.4. And then I'm gonna pass out the review today or email you the review. I recommend starting at that now and doing the problems you can do on your own based off of the notes and whatnot. Now remember, if you can do the review and I'm gonna upload the answers probably on Wednesday, because I gotta work through it. I make the problems, but I haven't done an answer key yet. So anyways, guys, so make sure that you guys are taking advantage of the My Math Lab and working on the assignments and showing yourself that you know how to apply the knowledge that you're getting from lecture. All right, guys, is that understood? Make sure you guys are, practicing and working. I know you guys have other classes, have jobs, have lives or parents. I get it. I do too as well, but I do my part. So make sure you're doing yours. Are there any questions, comments? Now I'm gonna read the people I have online so far on my math lab because we're missing a couple of students on there. And I'll probably do my thing and reach out to them since this is a census date. But for my math lab, who do I have? I have. So for this section, sorry, my internet's a little slow. And then you know how you have two sections in here? You have the lecture and then you have the math 105, the math prep. Well, the math prep is it's a core requisite for me to do additional lessons on there. But for today, I'm gonna dismiss y'all early just so y'all can have a little break between the next thing you do today. But I have Sarah, Gabriel, Iris, Manuel, Valishka, Kelsey, Bruno, Nicholas, Isabel, Miranda, Caleb, Jean, Emmanuel, Kayla, Ivan, Carly, Greg, Chris, and Emily. Now, the only one that has temporary access is Amaya. So I would like for you to stay online so we can take care of that temporary access and give you full access. Uh, is there anyone else on the Zoom call that does not have access yet to my math lab?